Welcome to Investigation 2.1, Connecting Congruent Polygons. So in this investigation, we are going to determine what the whole concept of congruency really is and how that can affect our ability to determine if a shape is only similar or congruent or if it's totally off. But in our focus question, we have, what does it mean to say that two geometric shapes are congruent to each other? How could you show congruence with movable copies of figures? So we're going to look specifically towards what does it mean to say that two geometric shapes are congruent. And we are going to be looking at various symbolism that we may need, and we're also going to create a missin page. So as we go through this, please get out your missin, label it Investigation 2.1, Connecting Congruent Polygons. If you'd like, you can also put the focus question in there. So if need be, pause this video right now. But I'm going to keep going. Here we go. So, one word worth knowing that I would like you to add is the word congruent. So the concept of congruency is this. Two figures are congruent if one is an image of the other under a translation, a reflection, or a rotation, or a combination of these. So in other words, if you can flip, turn, or slide a shape, or do a combination of those moves to make one shape fit exactly on top of the same vertices with the same side lengths and everything as the other shape, then those two shapes are congruent. So essentially, say this triangle right here is congruent to this triangle. They're totally not, but perhaps all we would need is to translate this triangle over and then flip it. If it were flipped, maybe those points meet exactly on top of one another, and then we have the side lengths that also meet. So that would be the concept of something being congruent to something else. So using that idea, we are going to move ourselves through our missin page. So here is our missin page. I'd like you to set it up something like this. If you look at this missin page, about a third of the way down, I want you to make a line, and that line can be a solid line. Just draw a line right across. Just a little bit above halfway, you're going to make another line. So this is going to be a skinny strip, skinny. Probably just 5 lines long. So it's going to be a skinny strip. But the top of it, that's not how you spell strip. That is, the top of this part is going to be about a third, and then the bottom should be about a half. So we have a half and a third, and then the remaining part is approximately a sixth or so. Let me think about that. Yeah, that would be about right, because a half, if I do this, is 3/6. We have a third, which is 2/6. And 2/6 plus 3/6 equals 5/6, so there's just 1/6 of your page left over. Sorry, that was a little side note. Fraction action, here we go. So you don't need to write this down in here, but essentially, if you see this various information, you're going to see where we're going next. We're going to start here with geometric terms and remember what they are. Then we're going to move on to congruence and similarity, and then we're going to have some symbols that we'll put right at the top of this, and then you'll be able to use the rest for your investigation. So you'll be able to do all the rest for the investigation, which will be kind of nice. So let's get started. First idea, the geometric terms. We're starting with the very top one, geometric terms, the top third. We have simply reflection, rotation, and translation. And we're going to put sort of layman's terms. A reflection, we can describe that as a flip. A rotation, we can describe that as a turn. And a translation is a slide. So essentially, a reflection is we're flipping something over something else. You might remember these drawings that we had from our investigation 1.4. We needed to find a line of reflection, which is approximately right there for that situation. We also need to find a line of rotation for this other one, so we need to find that turning point that we're turning around. And very last thing, we needed to find a translation for how we're moving all of these points for this other shape. So essentially, thinking about a reflection, we're talking about a flip. We're flipping it over a line so we have things exactly the opposite. Any distance that we have W and W prime, they're going to be the exact same distance away from the line of reflection. Same for X and X prime, Y for Y prime, and Z for Z prime. Last thing, we have rotation. It always turns around a point. It's always turning counterclockwise, so we can see that our original image is turning this direction. And then for a slide, we usually are talking about how far down and how far over is it going. So we could essentially look at this sort of line of how it's moving as sort of the slope of a triangle or the hypotenuse of a right triangle. So get this written down: flip, turn, and slide in relation to reflection, rotation, and translation. And if you'd like, you can draw yourself some brief pictures. If you need to, pause this video right now, but I'm moving on. Okay, so moving on. We are now in this section. So we just completed this. Those are rotation, reflection, and translation. Our next part is congruence versus similarity. So I'd like you to write congruence versus similarity, and then we are going to write different ideas that go along with that. Congruence, the concept of congruence is essentially you have the same angle measures, you have the same side lengths, but the shape is not always in the same orientation. So we can look at this shape, for example. We have this polygon, and you're going to be working with this polygon in this investigation. And we could measure some of the angle measures, A, S, P, C, all those different things. And we'd eventually find that this shape, even though it's not in the same position, A, B, C, D, is the same shape as this other one right here. And your job will be to determine how you would rename that shape. So we have polygon A, B, C, D is congruent, that's the symbol for congruence, which you're going to learn soon, is congruent to this shape in some form or another. Similarity is this concept. So we have the same angle measures in the same sort of setup as the others, but the side lengths that correspond to those angle measures, so we have W and its corresponding side length would be this one, they aren't the same. So the side lengths or the angle measures are the same, so we could say that this angle T corresponds to, oops, I wrote the wrong thing, sorry, corresponds to angle W, but, essentially, but S, oops, I am totally moving everything around, sorry, but ST is not congruent to VX. Essentially, SU and VX are not congruent. They are similar, but they are not congruent. So now that we've understood congruence and similarity, let's move on from here, and we are going into this section, symbols and investigation work. So for this particular part, we're just going to go through some symbols that you are going to want to have along the top of this, and the remainder of this page from like here down will all be investigation. So let's add some symbols. So let's zoom in a little bit and add some symbols. Oops, I'm just drawing on things. Let's zoom in a little bit. So one of our symbols that we have is our simple old equal sign. So I'll write that in a different color so we can see it. So we have just our equal sign. We know what that means. It's pretty exciting. It's awesome. The next one is this. This means, you might have heard it already, congruence. So essentially, if you have angle A is congruent to angle B, you would essentially write that in this way. So that leads me to my next one of angle. That is our angle sign. We also have one for line segments. So you would have the points that the line segments go between, and you'd have a bar there. So you'd say this is line segment A, B. We also have just this symbol. So that little symbol above the equal sign meant congruence. Just that little symbol without the equal sign means similar. And our last symbol is this, just an arrow. That arrow means corresponds to. So this is corresponds to. If we were to say, I'm going to put my little quotation marks. If we were to say angle A corresponds to angle B, that means we're looking at angle A on one triangle and angle B on another triangle, and we are making conclusions about those two angles. Perhaps they're similar. Perhaps, actually, if they're angles, they're going to either be congruent or not congruent. Perhaps they're congruent. Perhaps they're not congruent. If you're going to say angle A corresponds to angle B, you would then say that they are congruent. So that's kind of what we're heading to with all that. So let's zoom out a little bit, see if I have anything else. It doesn't look like I do. One other thing that I'd like to add is this whole concept of looking at a triangle and also having a few other ways to identify sides. So if we have a triangle ABC and a triangle FGH, we could say that angle C and angle H, sorry, I don't want to do a right angle. We don't know it's right angle. Angle C and angle H correspond to each other, but we could also say that B and G correspond to each other. However, they're different angles. So one way that I indicate that is with the different numbers of angle markers. So like marking two angles for B and G, saying those are congruent and they are equal to each other on those particular sides, and C and H are congruent. They have another one. You would maybe say for angle A, 3 tick marks, and angle C, 3 tick marks. One other thing that you can do is for sides, you can just put single ticks through there. So those two sides, line segment A, B, is congruent to line segment FG. So those two line segments are the same. So if we're following that same sort of pattern that we did before, AC, we could say that's 2 tick marks because it's a different length. And then BC, we're going to have 3 tick marks because, yet again, it's another length. So considering all those ideas, there are multiple ways that we can describe what's going on in investigations 2.1 through 2.3. I hope this helps. I want you to start working on investigation 2.1, and you're going to be working through investigation 2.1 A through D. A through C should be pretty self-explanatory after we've gone through all this, and D should be the only hard part where you actually have to look at a shape and make it transfer onto its image. So play around with this investigation. Make sure you are precise with ankle rulers and rulers themselves, and I will talk to you later. Thank you so much for watching, and I'll see you later. Bye.